Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, soleh-soleha, for today we can meet in our uh, class ya by Zoom. Okay, for today, before we start our lesson, it is good if we pray before. And please, Wahid Isnani Salasa. Bismillahirrahmanirrahim. Rabbi zidani ilman warzuqni fahman wa alimni bisolihin. Amin ya rabbal alamin. Okay, for my student in stage 3, it I like before I say for the exercise in your book in a page number 138, I give you instruction for answer it for today, but it's never mind. It is okay if you done to answer it. Because I have a little information, I have a little explanation before we answer it. This question. Okay, I will show the book. Now this you can open your book. Yeah, what page number? 136. Nah, this about the different, yeah. This a Forcemeter. We can use a Forcemeter to measure the force needed to make a block start moving. And what will happen, the reading on a Forcemeter if we place something heavy on a block. So we can, I think for my student, you already know how to reading the Forcemeter. It's like this, yeah. We read this scale. And then what is the different? What is the different from the second picture here? For the first, this is only block, and a pulling force is applied to make a block start moving. This, yeah, we pull and then the block will be start moving. And as we know, the surface is same. Yeah, the surface is same. And then for the second picture is a heavy rock is placed on the block. A pulling force is then applied to make the block start moving. You now what is the difference? This is only block. We pull only block, and then this we add a rock. Yeah, uh so we pull a block and a rock, So we can now where's the heaver? Yeah, where's the heaver from the picture? It's of course the heaver is by the second picture, because this block and rock, so it's heavy here. If we compare then this block. Okay, I have video. Wait a minute, I will be show my video. Okay, please, my student, please hear the explanation from start.
It takes a lot of effort to push it, but pushing a smaller table is much easier. All movement is opposed by a force called frictional force, which acts in the direction opposite to the direction of motion. Let us conduct an experiment to study the effect of mass of an object on frictional force. For this, we need a spring balance, weights, wooden plank with a nail fixed on one end. Place the wooden plank on a smooth surface, attach a spring balance to it. Now pull at the wooden plank with the spring balance till the plank starts moving. Note the reading on the spring balance while the plank is moving. It reads 1 gram. This number indicates the amount of force required to overcome the frictional force and make the plank move over the surface. Now put 100 grams of weight on the plank.
Please look, yeah, the surface is same. The surface is same, it's not change the surface. And what is the different about these things with if we want to pull it? Please look, what is the different?
Again, pull the plank with the spring balance. Note the reading in the spring balance. It reads 25 grams. Now place another 200 grams on the plank. Again, pull the plank with the spring balance and note the force applied. It reads 65 grams.
The heaver, yeah.
Now we will increase the weight to 500 grams and note the reading. It reads around 115 grams. We observe that the force required to move the plank over the surface increases with the increase in the mass of the plank. This means that the frictional force that opposes movement must also increase with increase in the mass of the moving object. Frictional force is defined as a force which opposes the motion of a body on any surface. It acts on both the surfaces involved. Take an empty suitcase and another filled with objects. Now slide it across the floor. Can you tell why is it easier to move the empty suitcase?
Okay, this basic or the explanation uh, about the before we enter to the friction, because for the next week we want to learn about the friction, and then this video it's will be relate with this. But before we uh, must to answer it the our exercise that relates with the same surface. Yeah, same surface. Wait a minute, I will be show that's our exercise for the number two. Okay, now please, my student, please open your book, page number 138. 138. This for continue. That we have um exercise yesterday for the number two is Henry and Gita took turns using a force metal to pull their shoes across the floor, and they want to find out whose shoe needed a larger force to make it start moving. Please look, this is the blue shoes is by Henry, and then Gita has orange shoes. What is the result? From their experiment or investigating, they have a result and then enter it to the table. For shoes by Henry, reading on force meter in 6 Newton. And then Gita is for Newton. And then for the question, yeah, for the part A, based on the result from investigation Henry and Gita, whose shoe needed a larger force to make it start moving? Whose shoe needed a larger force? So this you can choose it. Where is the big uh of the reading on a force meter to answer this? Yeah, the larger force it's heavy. It's heavy for the shoes or the things, so it's needed the larger force to pulling their shoes. You can look from the reading on a force in Newton. And for part B, why should the children carry out the experiment on the same floor? Why the if um Henry and Gita shoes must be pulling their shoes in its same floor? Why it's not different? Yeah, please you must be answered. If they are doing this experiment in different floor, but they is doing this experiment on the same floor. Yeah, same floor. Like in our video before, if you do in a smooth surface, you must be do it the two or both of your experiment into two. Ya, jadi kalau kalian mau melihat the same shoes and shoes, you must be investigate or doing experiment in a same surface. If you have a rough surface, kalau kasar permukaannya, silahkan dilaksanakan di keduanya itu dilaksanakan di bersamaan, ya, bersama atau sama permukaannya, it's raw atau kasar. Of if you do it in a smooth, kalian harus melaksanakan keduanya. You do investigating di uh, permukaan the smooth floor atau di permukaan yang sama. Why can? Kenapa kita harus doing this experiment in a same floor. You can give a reason why we must be do this experiment in a same floor, and then you can do it. Why if the we do this experiment in the different floor, this relation about the friction or what we want to do to the next. Yeah, so only about your opinion. Yeah, give opinion why should the children carry out the experiment on the same floor. Jadi berikan saja pendapatnya why this experiment must be have a same floor or we do in a same floor. And a part C, Gita placed some glazed marble inside her shoe. Dia menambahkan glass marble inside her shoe. What happened ya? Will the force needed to make her shoe start moving increase or decrease? If the Gita memasukkan kelereng inside their shoes, what will be happen? That's uh, what happened with their force, it will be increase or decrease, apakah lebih membutuhkan gaya atau tidak, it's meningkat atau menurun gaya yang diberikan if Gita place some glaze marble inside of her shoes. Okay, okay, for my student, give your opinion about this question about this experiment. Have enjoy, and you can send me take a photo ya for number one. Yeah, please take a photo number one and number two and send to me, and you can send to Ustazah Wana. Okay, I say thank you very much. Assalamualaikum warahmatullahi wabarakatuh.